Hello, this video is for the IXL activity titled Solve Absolute Value Inequalities. The three-character code for this activity is Hotel X-Ray Hotel, and at the time of this recording, this activity can be found in Algebra 1, Section L, Activity 3. Absolute value inequalities. Well, they're kind of like absolute value equations. That's why I have an example of an absolute value equation over here to the side. Now, whenever we solved absolute value equations, we realized that we have to make two separate equations. So we took what's inside of the absolute value brackets, and then we set that equal to our answer over here. And on the other one, because we have to do two of them, we're going to have plus 10 equals, and then we want a negative form of it. So we would do negative 40. So notice what I've done is I've taken what's inside of the absolute value bracket, and I put it into each equation on the left side of the equation. And I've also taken the answer and made a positive form of it and a negative form of it. So let's go ahead and solve these real quick. I want to subtract 10 to get rid of the positive 10. It's going to leave me with just Q. 40 minus 10 is 30. And on the other one, let's subtract 10 from each side. That would leave me with Q on the left, and negative 40, negative 10. It's going to give me negative 50. We can see that these are correct because if we plug them back into our absolute value equation, we would get a correct answer. 30 plus 10 is 40. Absolute value of 40 is 40. Negative 50 plus 10 is negative 40. Absolute value negative 40 equals 40. So in this case, I know I have the correct answers. But it's the process that I want to point out, is that we take what's inside the absolute value, put it into both equations, and we set the answer to a positive form of it and a negative form of it. Now, absolute value inequalities over here. Now, one difference is that we're using inequality symbols, like greater than, less than, greater than equal to, less than or equal to. And another similarity is that we're going to create two separate inequalities. The difference is it's the other side that we're going to make a positive form of it and the negative form of it. So let's take a look at what I'm talking about. Take what's inside. Well, let's do a rewrite. Always good to do a rewrite. U minus 1 less than 5. So absolute value of U minus 1 less than 5. Let's take what's on the inside. Create a positive form of it. Less than 5. Now we want the negative form. So we're going to put it in parentheses. U minus 1 with a negative sign out in front of it. And we're going to bring down our inequality symbol. And we're going to leave our answer positive. So notice this time we left both the answers positive. Instead, we did a positive form of what's inside the absolute value and a negative form of what's inside the absolute value sign. So let me get rid of those underlines. Now let's go ahead and solve. Let's go ahead and add 1 to each side. We do to one side, we do to the other. Those ones cancel each other. You leave me with U and less than 5. And then the other one, this means the opposite of the quantity of U minus 1. Basically, what this negative sign out front does is it changes the signs of everything inside the parenthesis. So my positive U becomes a negative U. My negative 1 becomes a positive 1. Bring down my less than sign and 5. Now let's go ahead and subtract 1 from each side. Those ones cancel each other, leave me with negative U. Bring down my less than, and now I have 5 minus 1. In this case is 4. Now I can't leave this negative U there. It has to be a positive U. So what I'm going to do is I'm going to divide by negative 1. And what I do to one side, I do to the other. It's a 1 there. There we go. But since I divided by a negative, I have to flip the sign. The negative 1 is going to cancel out the negative sign up here. I'm just going to have U. And positive divided by negative is negative. 4 divided by 1 is 4. So I now have two answers. U is less than 5. And the other answer of U is greater than 4. Now you will notice that they want our answer to look something like this. And whenever we did compound inequalities before, we recognized that this is an AND situation. It has three parts, just like the word AND, A, N, D. So AND situations look like this. And then OR situations will look just like this. And our example is that it's like the oars of the boat. We know that the signs point outward, right? And the variables always come first in the statement, followed by the sign, and then the number values. All right, so I'll go ahead. We'll build those up as we go through. I'm going to erase that, keep it kind of cleaned up and looking good. So in order to realize, do we have an and situation or an or situation, I'm going to use a number line, and I'm going to graph my solutions. So I'm going to put a number line over here, and actually I want that to be a white number line. It's going to show up a little bit better. Still had red highlighted. There we go. And now let's find my 2 points. 5 and -4 is what I need on the number line. So I'm going to put -4 down here, and I'm going to put +5 over here. One of my examples is u is less than 5. So we're talking about everything this way, right? If we graphed it, graph would look like that. And let's use blue for the other one. And anything greater than -4. So greater than -4 would look like this. So our answer lies in the overlap. This is an and situation. Since we have some overlap, it's going to be -4 and 5. So this is an and situation. So let's go ahead and get my red pen here. And we know that with an and situation, the x is going to, or the variable goes in the middle. Both of our arrows point to the left, and they're both less than or greater than signs, no equal sign. We don't need the equal sign anywhere. And the lower value always goes on the left, -4, greater value always on the right, +5. So this would be the correct answer to this problem here. Let's go ahead and take a look at the next one. This one here is a little more difficult. Now I do want to point out that in the directions, it says that we can use integers, proper fractions, or improper fractions, and they want them in simplest form. So let's go ahead and do a rewrite first. Absolute value of 7b plus 2 is greater than or equal to 85. Well, let's follow that process. Make a positive and a negative form of what's inside of the absolute value symbols. So we'll do positive form on the right, 7b plus 2, greater than or equal to 85. And then we'll do our negative form of it over here. Put what's inside the absolute value brackets into the parentheses. 7b plus 2, close that parenthesis, less or greater than or equal to 85. So let's go ahead and work the positive one first. Let's get rid of that positive 2 with a -2. And what we do to one side, we do to the other. 2's cancel each other, leaving us with 7b. Bring down our greater than or equal sign, and 85 minus 2 is 83. Now the 7's tied to the b through multiplication. Let's go ahead and divide by 7. What we do to one side, we do to the other. 7's cancel each other, leaving me with just the b. Bring down my sign, and 83 over 7. 7 will not go into 83, so I cannot simplify this to a nice whole number. So I'm going to leave it as a fraction. It is indeed an improper fraction, but that's okay because our directions say that I can use an improper fraction. Now for the negative sign, remember the negative sign is just going to change the sign of all the values inside the parentheses. So positive 7b is going to be a negative. Oh, go back. I got to write over that with white. There we go. Negative 7b, and the positive 2 will become a -2. Bring down our sign, 85. Let's go ahead and add 2. Get rid of that -2. We do to one side, we're going to do to the other. Those 2's will cancel each other, leaving me with -7b. Bring down my sign. 85 plus 2 is 87. And now let's divide by -7 to get rid of that -7 over there. I just divided by a negative, so I do want to flip my sign. Don't forget the equal portion. And -7's will cancel, leave me with b. And 87 divided by 7, well, 7 doesn't go into 87 to create a simplify to a whole number, so I'm going to leave it as an improper fraction. And I like my negative signs up at the numerator, so I'm going to go ahead and put that negative with the 87 up there at the top and 7 at the bottom. So I have two solutions. B is greater than or equal to 83 over 7, and B is less than or equal to -87 over 7. Let's go ahead and graph this out on a number line. And in this case, I'm going to have one number down here. This is going to be easy because negative numbers are going to be on the left, right? And then down here is going to be my positive 83 over 7. Good. And let's look at the first one. The first one is anything greater than or equal to 83 over 7. So down here, I want a line that's going to the right to show everything greater than. And indeed, I also want to make it a solid dot. And then the other one is everything less than or equal to negative 87 over 7. So that's going this way, everything less than, right? And it should be a closed dot. So in this case, I know I have an OR situation. It's going to be OR goes in the middle, and just like the oars on a boat point outward, we're going to build our left OR over here. We're going to build our right OR over here. The X always comes, or the variable. Do we have X's? No, we're doing B's this time. So let's go ahead and get rid of that variable X and make it a B. And the arrows point outward, like the oars on a boat. Both of them have the equal concept. So we'll put that in there. The lesser value goes on the left, negative 83. Oh, that's a positive 83. Go back, go back, go back. That's the negative 87. There we go. Over 7. I just didn't make a very good 7 right there. And the positive 83 over 7. So that would be our correct answer there. And I'm not going to, for the sake of time, I'm not going to read over it. On the next question, there we go. First thing we have to do is isolate the variable, or isolate the absolute value portion of the inequality. So just like I have this x plus 3 is greater than 0, just like the idea is to get the x all by itself, right? And by doing that, we would subtract the 3. What we do to one side, we do to the other. And then we isolate the x on one side by doing so, using an inverse operation. And here we'd end up with negative 3. So the idea is to get the x by itself. Well, likewise, before we can split this into two separate inequalities, we have to first isolate the absolute value portion of the inequality. That means we need to get this part all by itself. So let's go ahead and I'm going to do a rewrite. Absolute value of y. And we're going to subtract 3 greater than 0. So let's go ahead and first add 3 so we can get that absolute value portion all by itself. Those 3's would cancel each other. And then what would that leave me with? Absolute value of y greater than positive 3. Now let's create a positive form of it. Take the y greater than 3. Well, there's one of our solutions already, right? And then the negative form of it. So the opposite of what's inside the absolute value symbol, y greater than 3. The opposite of positive y is negative y. And now we want to go ahead and divide by negative 1. So that means the signs on both of those are going to change and our symbol is going to flip. So negative y becomes positive y. Flip the symbol. Positive 3 becomes negative 3. We have our two solutions. Let's go ahead and grab a number line. Plot our two numbers. One of them is negative 3. The other one is positive 3. For one of them, it says all y greater than positive 3. So that would be this way. Looks like it's going to be an OR situation, right? And then the other one is all values less than negative 3. So that's going to look like that there. So we definitely have an OR situation. So let's go and build our answer. Put our word OR there. Variables come first, and this time we're using a y. The signs point outward like the oars on a boat, and the lower value goes on the left oar, upper value on the right oar. So negative 3 here, positive 3 there. That is our solution. Next question. Let's go ahead and do a rewrite. 4 times absolute value of negative 4z. Close the absolute value, and that's supposed to be less than 96. So first thing we want to do is go ahead and isolate that absolute value portion. Well, it has a 4 that's being multiplied by it, so let's divide by 4. And what we do to one side, we'll do to the other. Those 4's cancel each other, leaving us with absolute value of negative 4. And don't forget the z. Hold on, let's put that z in there. And that's supposed to be less than, and then 96 divided by 4, what is that, 24? Because 100 divided by 4 is 25, so 96 divided by 4 is 24. Now, let's see. I think I want a little bit of room to work this, so I'm going to go ahead, grab all this, and I'm going to slide that over to the side. That was my work that I did in order to isolate the absolute value portion. So now that I have that, I can continue on. Let's take the positive form of it. So just take what's inside the absolute value bracket, write it outside, less than 24, and then a negative form of it. What's inside the absolute value? Negative 4z. Close the parentheses, less than 24. So let's divide by negative 4. What we do to one side, we do to the other. And since I divided by a negative, I want to flip that sign, right? Those cancel each other, leave me with z. And then positive divided by negative is negative. 24 divided by 4 was at 6. So negative 6 is one solution. The other one, what's the opposite of negative 4z? Well, it's a positive 4z. I'll bring down my sign, bring down my 24. And now let's go ahead and divide by 4. Not going to change the sign because I'm dividing by a positive number, right? 4's cancel each other, leave me with z. And 24 divided by 4, once again, is 6. So my two solutions are z is greater than negative 6 and z is less than positive 6. I think this is going to be an and situation. Let's double check. Make my graph there. Plot the lesser value, negative 6, the greater value, positive 6. Go ahead and let's look at the first one. Everything greater than negative 6, so that's going to be everything going that way. And then everything less than positive 6, it's going to be everything going this way. So we do have some overlap between negative 6 and positive 6, so this is going to be an and situation. And we can write and situations with the variable in the middle, which is z. Both arrows go left. And yep, they should both be no equal sign, right? And also our lesser value on the left, greater value on the right. So that is the answer to this particular problem. All right, here's one that's kind of tricky. It's got the negative sign inside, and we've seen that with that negative 4z just a moment ago. So let's do a rewrite. Negative s greater than equal to 6. It's already isolated, so we don't have to do anything there. Let's go ahead and take the positive form of it, take what's inside, and just do a rewrite. And then negative sign in our parentheses, right? What goes in the parentheses? What's in between the absolute value bars? Then bring down the sign and the 6. So we need to divide by negative 1, both sides. Whenever we divide by negative, we're going to flip that sign. Those cancel each other, leaving us with s. And negative, positive divided by negative is negative. 6 divided by 1 is 6. So there we have one solution. And then the opposite of negative s is positive s. Bring down the rest of it. And there we have our second solution. Go ahead and create our number line. And put it over here this time, right? And let's plot our lesser value, negative 6, and our greater value, positive 6. Now let's see. Graph these out so we can see is it an and or an or situation. Let me see, less than negative 6. So that's going to be that way. Looks like an or situation, right? And then everything greater than 6. So that's this way here. Good to go. So we know we have an or situation. Let's build the left or. Variables always come first. The variable here is s. Variable first. Signs point outward like the oars on a boat. Lesser value on the left oar. And greater value on the right oar. There's our solution for this problem. Here we have that 6 is tied to that absolute value of y plus 6. So we're going to have to go ahead and isolate that. So let's go ahead and do a rewrite. 6 times the absolute value of y plus 6. And this is supposed to be greater than 39. So let's divide by 6. This might be a fraction, right? 6's cancel each other, leave me with the absolute value of y plus 6. And notice that 39 divided by 6, that's not going to work out real pretty. It won't make a whole number. We could simplify this, though. I believe they're both divisible by 3, right? Let's look at that. 39 over 6. 39 divided by 3 is what, 13? 6 divided by 3 is 2, so we could simplify that to 13 over 2. Let's go ahead and grab the work that we did to isolate it. We'll move that off over to the side. We'll leave it there so we can see what we've done to get to this point. Now let's go ahead and work on the other side there. Positive form of it is y plus 6 less than and 13 over 2. And the other one is the opposite of y plus 6. And that's supposed to be greater than 13 over 2. And let's also move our equivalent fraction over here to the side. And now I'm ready to go ahead and solve my two inequalities. So on the left one here, make sure I'm in white, there we go. Let's go ahead and subtract 6, and what we do to one side we need to do to the other. But here what I'm going to do is, this is a little different. I need to subtract 6, but it's a fraction. So I'm going to put it horizontally instead of stack it, or vertically. No, horizontally, that's right. So instead of putting it under, I'm going to put it over here to the side. I want to subtract 6. But I want to write 6 in such a way that the denominator has a 2. Well, 6 times 2 is 12, so 12 over 2 equals 6. So I'm just writing 6 in another form using the improper fraction of 12 over 2. The y's can't, the 6's cancel each other, leaving me with y. And then 13 minus 12 is 1. And here I get 2, so y is greater than 1/2. Now let's do the negative 1. Opposite of positive y is negative y. And opposite of positive 6, negative 6. And over here, now bring that down. Let's go ahead and bring that down. 13 over 2. Getting a little bit crowded there. Let's move this just a little bit. Move that up there just a little. There we go. Now let's go ahead and add 6 to each side. Well, here I'm going to add 6, but it's in a fraction. So just like I had 6 is 12 over 2 here, I'm going to write it as 12 over 2 here. So I'm adding 6 to each side. Those negatives cancel each other, leaving it negative y. Let's bring down my sign. And 13 plus 12 is 25. Denominator still 2. Now I have y is negative. I want to make it positive. Means I'm going to flip the sign. And if I'm going to change the y from negative to positive, then this is going to have to go from positive to negative. Negative 25 over 2. And there's my other solution there. So is this an and or an or situation? Let's use this space right here. That looks good. And I have two numbers. Lesser value is going to be the negative number, negative 25 over 2. And the greater value is going to be 1/2. And on one of them, let's see here, greater than 1/2, going to be an or situation, right? That or goes out. And this one here is less than negative 25 over 2. So it's definitely an or situation. So let's build our answer up. Throwing that word or, our left or and our right or. Variables come first. We're using a y. So put the y's first, and arrows point outward, like that of the oars of a boat. Lesser value on the left oar, and the greater value on the right oar. And let's double check. Yep, indeed, both of them are the signs with no equality concept. So there's the answer to that problem. Here we have 5 times the absolute value of negative z minus 3 minus 9 greater than 6. So got a few steps here. These are the more complicated ones. First, let's get rid of the negative 9 with positive 9. What we do to one side, we do to the other. Those 9s would cancel each other, leaving us with what's left up here, which is 5 times absolute value of negative z minus 3 and greater than, and 6 plus 9 is 15. That's going to work out real nice because now we need to divide by 5, right? What we do to one side, do to the other. Those 5s cancel each other, leaving us with absolute value of negative z minus 3 greater than, and 15 divided by 5 is 3. So let's take all this work that I did here to get it isolated, and we'll move that over to the side there. Let's move our isolated portion here up there so we can go ahead and work it, split it into two separate sections. I hope you're using paper to do these. Trying to do this in your head would be awfully complicated. Strongly require you to do as you see me doing and work each of these problems out. So let's take the positive form of it, write what we have in the absolute value portion, and bring our sign down in 3, and then the opposite of it. So what's inside of the absolute value brackets goes in the parentheses. Let's do that positive one first. Let's get plus 3 to each side. Those cancel each other, leaving it negative z. And 3 plus 3 is 6. Can't leave that z negative, so I'm going to make it positive. I'm basically dividing by negative 1. But dividing by negative, required to flip the sign, and this is going to become negative 6. So there's one solution there. And then the opposite of everything inside the parentheses. Negative z becomes positive z. Negative 3 becomes positive 3. Bring down the rest of it. Let's go ahead and subtract 3 from each side. Those cancel each other, and I get z. And greater than, and 3 minus 3 is 0. So there's my other solution there. Grab our number line so that we can graph it. Put that over here. Two values, lesser value on the left, which is 0, and greater value, oh, no, it's not. That's a negative 6 there, so let's go ahead and put that as the lesser value. Negative 6 and 0 on the right. So let's see here, what have we? Or and situation. So greater than 0, oh, it's going to be an or situation, right? And less than negative 6. Let's go ahead and build our answer up. We have the word or, our left or, variable always comes first. We're dealing with z this time, so we'll put a z on both the ors. The arrows always point outward like the oars of a boat. And our lesser value on the left or, negative 6. Greater value on the right or, which is 0. So our solution for this problem is there. All right, I believe that this is my last one, I think. Nope. Well, I wasn't planning on it to be my last one, but I'm going to make it my last one for the sake of time. This one's gone pretty long. So let's see here. Oh, that's not what I wanted to do. Let's do a rewrite. So negative 6, absolute value for t, plus 1, close the absolute value, plus 9, greater than, equal to negative 5. So let's go ahead and get rid of this positive 9 with the negative 9. What we do to one side, we're going to do to the other. Those cancel each other. Bring down that negative 6 that this is everything we still have here. Negative 6, absolute value for t plus 1. Greater than, equal, and negative 5 plus a negative 9 is going to be a negative, what, 14? Looks like we're going to end up with a fraction here. Let's go ahead and divide by negative 6. We're going to divide by negative, so that means our sign's going to flip. We're going to flip that sign. Those cancel each other. Leave me with the absolute value of 4t plus 1. And negative divided by negative is positive. 14 over 6. We're going to leave this as an improper fraction. 14 over 6. And they're both divisible by what? 2, right? 14 divided by 2 is 7. 6 divided by 2 is 3. So we'll go with 7 over 3. Because like it says, we want it in simplest form. And we can't have it as an improper fraction. So we're good to go there. Let's take all the work that we had here to isolate that portion of it. We'll move that over here. And then let's take our isolated absolute value section there. Got it to this point. And let's go ahead and split it into two separate equations. First, the positive form, 4t plus 1 less than equal to 7 over 3. And then over here, negative sign, parentheses. Well, let's put that 4 in there. Grab that. Erase that. 4t plus 1. And this is less than equal to 7 over 3. So let's go ahead and add 1 or subtract 1 from each side. Or yeah, we're doing that there. So I want to subtract 1 here, but I want 1 where I have a denominator of 3, and that's going to be 3 over 3, right? So 1's cancel, leave me with 4t. And 7 minus 3 is 4. The denominator is still 3. Now I need to go ahead and divide by 4. Boy, this one's going to be a little bit of work. Should have checked into this one first. So I'm going to divide this by 4 and put that as 4 over 1 as a fraction. It's going to leave me with just t over here. Well, this one's a fun one. So let's do 4 over 3. We're dividing fractions, so we're going to keep flip chains. We're going to keep the 4 over 3, flip the second one, 1 over 4, change the sign to multiplication. 4s would cancel, become 1s, and 1 times 1 is 1, and 3 times 1 is 3, so my answer is 1/3. Boy, that's fun. And now let's do the other side. The opposite of positive 4 is negative 4, so it's going to be negative 4t. Positive 1 becomes negative 1. Bring down my sign. And 7 over 3. Now let's go ahead and add 1 plus 1. And what I do to one side, I do to the other. So 3 over 3 is going to be 3 over 1 is going to be 3 over 3. There we go. Those will cancel each other, leaving it negative 4t here. Less than equal to, and 7 plus 3 is 10 over 3. And now I need to go ahead and divide by negative 4, right? And I'm dividing by a negative, so my sign's going to flip. And this here is divided by negative 4. And I'll write this negative 4 over 1. And those cancel, leaves me with t there. And then let's do 10 over 3. Keep the first, flip the second. 1 over negative 4. I should have kept the negative in the numerator. I prefer it that way. Change the sign. So 10 times 1 is 10. 3 times negative 4 is negative 12. This is equal to, I want my negative sign back up top. They're both divisible by 2. 5 over 6. There we go. Negative 5 over 6. Wow. All right, I need a little space here, so I'm going to go ahead and erase all of this because I want to graph that out so I can build my answer. I'll make this the last one, even though I have another one scheduled in there. But put my line in there. Two values, lesser and greater. The lesser is going to be the negative 5 over 6. The greater is going to be 1/3. And so this one here, do we have a or and situation? It looks like it's going to be an and. Less than 1/3 and greater than 5/6. We'll graph that in a different color. Greater than negative 5/6. So we do have an overlap here between the negative 5/6 and the positive 1/3. So let's go ahead and build our answer. This is an and situation, so we need the variable in the middle. Both of them point to the left. Lesser value on the left side, greater value on the right side. And let's check our signs. Yeah, they both have the equality concept, so we need to throw that in there. Good to go, and that is our final answer there. All right, so those are all of my examples for solve absolute value inequalities. Now, go level up your learning.